The pursuit of new chemical compounds has always proved to be a fascinating journey, and chemical invention has created several major technological steps forward, though not, however, without unpredictable and dire consequences. Back in 1974, two American scientists published a theory which claimed that the apparently harmless gases used in refrigerators and spray cans were destroying the protective and delicate ozone layer in the atmosphere. Should the theory prove to be true, it would not only mean a substantial increase in the numbers of those contracting skin cancer, but also have completely immeasurable consequences for food production. So, for several years, scientists worldwide were searching for proof of the validity of this theory, without success. Nevertheless, should the theory be proven, mankind would face yet another fatal dilemma.
This little can with a button on top is used in hundreds of ways to make your life easier and more pleasant. It contains an aerosol. And of course you know what this is. Now what do these two things have in common? Well, the answer is Freon fluorinated hydrocarbons, used as cooling agents in the coils of your refrigerators and as propellants in aerosols of all kinds. This beaker contains liquid
The history of
Freon,
Freon, or CFC gases, began in the 1920s with the mass production of refrigerators, in order that foodstuffs could be both safely stored and for longer periods.
Before the era of refrigeration, lots of food would spoil, and so food would be wasted. People would get basically upset stomachs, more serious effects from food poisoning. So the advent of refrigeration was absolutely critical.
Although the very first refrigerators which came on the market soon proved to be popular, they were also a health hazard.
The refrigerants that were first used were very dangerous. They were ammonia, they were sulfur dioxide, they were chemicals that could be directly toxic or they could damage food. There were many stories in the local newspapers about families that would die from a leaking refrigerator, or about health problems such as breathing problems that would be made worse. There were fires and explosions. So it was a very dangerous time in refrigeration and air conditioning.
Manufacturers of refrigerants, such as the cooling division of General Motors, rushed to develop a safer compound, with their most noteworthy scientist Thomas Midgley discovering a refrigerant in 1930 which was trademarked as Freon. It was both non-flammable and non-toxic, and to prove his point, Midgley inhaled Freon and then afterwards blew out a candle, much to an impressed American Chemical Society assembly.
Sometimes they would say safe as milk, that it was perfect in every way and that it was a miracle chemical, and it was proof that chemistry could solve any problem that people would have.
The application of CFC gases in refrigerators became a huge success, and their usage quickly spread to dishwashing sponges, foam rubber, foam insulation, and aerosol cans.
Today, Freon, made by DuPont, is used as the power plant in many, many types of aerosol products. They make your life easier, safer, more pleasant. Better things for better living through chemistry.
By the 50s and 60s, the average American household had around 40 different assorted aerosol cans in use: hairspray, insecticides, paint sprays, etc., such that the consumption of CFCs emitted into the air rocketed to almost 1 million tons a year. But the question was, where did they end up? English scientist James Lovelock resolved to measure the level of CFCs in various parts of the world, and developed an electronic instrument capable of measuring microscopic concentrations of CFC, down to 1/1,000,000th.
For 30 years, CFCs were put into the atmosphere and no one bothered, or could indeed, measured them in the small quantities that were there. And then Lovelock came along, and he was able to make enough measurements around the world. He actually went on a cruise to the Antarctic and back, measured the latitude gradients of all the CFCs, which of course had never been released in those days in the southern hemisphere, and it was possible to do some sums, which very crudely interpreted said 99% of all the CFCs ever released are still in the atmosphere.
When the American scientist Sherwood Rowland read about Lovelock's measurements, he and colleague Mario Molina decided to investigate what happened to these stable gases and developed a theory that changed our view of the world.
I knew from the experiments that we were doing in the late 60s and into the 70s that the chlorofluorocarbons could be decomposed if there was just enough energy about them. So when you read that Lovelock had detected these in the atmosphere, the question then came up, I wonder what happens to it.
Rowland and Molina concluded that the gases rise slowly up into the stratosphere, the upper layer of the atmosphere, where they mix with the ozone layer, the protective shield against the sun's harmful ultraviolet rays. And here, the sun's rays liberate chlorine from the CFC, which in turn then attacks the ozone before breaking free again, and thus a chain reaction has begun.
On the average, you lose about 100,000 molecules of ozone for every chlorine atom you produced. And when you go back to 1 million tons of chlorofluorocarbon released in the atmosphere, roughly, every year, and they're talking 1970s, and then you multiply it by 100,000, that begins to be an amount that is important on a global scale.
Rowland and Molina calculated that if the production of CFCs continued to rise at the same rate, the gases, which by 1995 would have caused a global ozone depletion of 7%, would by 2050 have destroyed somewhere between 30 to 50%. An alarming calculation indeed, because it meant that yet even more of the sun's harmful ultraviolet rays would reach the Earth's surface and would affect both vegetation growth and cause a marked rise in skin cancer.
Your first reaction is, somewhere we've lost a factor of 1,000. So we better check this calculation. And we did and realized that we hadn't. So at the American Chemical Society meeting in September of 1974, that's when I said that in press conference that we think that CFC, manufacture and release of CFCs should be stopped. And that put the fat on the fire.